Dear friends, in this video we are going to discuss about problems on steam nozzles. In both the methods, I am going to discuss the problem, that is by using molar diagram and by using steam tables. So let me read the problem. The dry saturated steam at a pressure of 10 bar is expanded in nozzle to a pressure of 0.75 bar. So the pressure at this point is, here it is 0.75, whereas here it is 10 bar, here it is 0.75 bar. So here the 10 bar, here it is 0.75 bar. Find the velocity and dryness fraction of the steam issuing from the nozzle if the friction is neglected. There is no friction loss. Also find the velocity and the dryness fraction of the steam if 10% of the heat drop is lost to friction. There are two cases given. One case is without friction, another case is with the friction of 10%. So this is the thing we have to understand. Here the pressure is 10 bar, here the pressure is 0.75 bar. We have to find velocity of steam leaving the nozzle C2 and C2 dash, that is without friction and with friction. Also dryness fraction with friction and without friction. So there are two cases here we have to deal. Case 1 is friction is neglected. Case 2 is 10% heat drop in due to friction. First we will deal friction is neglected. As we know the formula for exit velocity, C2 equal to square root of 2000 into enthalpy difference, that is heat drop plus C1 square. If initial velocity is 0, we can take C1 equal to 0. So the formula becomes 2000 into heat drop within the square root. First we will deal with the molar diagram. This is a molar chart. This one is enthalpy. Here it is entropy. So for the given condition at 10 bar pressure, dry saturated, that is this line is called dry saturated line. This line is called dry saturated dark line. This is called dry saturated. This is below dry saturated, that is less than 1. Here x equal to 0.1. Dry saturated at 10 bar pressure, this is the point we have to understand. At this point, draw the horizontal line that will give the enthalpy. Draw vertical line that will give the entropy. So like this we can find out H1 and H2. And we are finding the dryness fraction is 0.86. Since the expansion in the nozzle is always isentropic, that is entropy equal to constant. Entropy at 1 is equal to entropy at 2. So S1 equal to S2. S1 is at pressure 10 bar, S2 is at pressure 0.75 bar. So we can easily find out H1, H2, S1, S2 and dryness fraction X2 also. So we have found dryness fraction as 0.86 when the steam leaving the nozzle. So H1 we know, H2 we know, and we can find out exit velocity without friction is 921.95 based on the molar diagram. So I hope you easily understand this problem. From the molar diagram for the given pressure, we can find out H1 and H2 and dryness fraction. So by using the simple formula, C2 equal to 2000 into H heat drop within a square root. So we can find out exit velocity and exit dryness fraction. Case 2, that is a 10% friction loss, heat drop due to friction loss. Nozzle efficiency is given. So in the formula we have to multiply the nozzle efficiency. So look at the formula. Here we are multiplying by nozzle efficiency, that is 0.9. It is given in the problem. 10% heat drop, that is 0.9. We have to multiply by 0.9. So C2 dash is with friction. So 2000 into H1 minus H2 dash. H1 minus H2 dash by H1 minus H2 is the nozzle efficiency. That is 0.9 equal to nozzle efficiency is equal to 0.9 equal to C2 dash equal to 874.64. That is nozzle efficiency H1 minus H2 dash equal to H1 minus H2 that is H1, H2, 0.9, and we are finding the H2 dash. P2 dash, H2 dash we have found. Now take the same one, P1 equal to 10 bar, H1 we have found, H2 is a 0.75 bar, meeting point 0.75 bar. Here it is termed as 0.22350. This is the H2 dash is, this point is 2392.5. 2392.5. There we are going to find out dryness fraction. 2 dash dryness fraction is 0.88. This is the dryness fraction of when the steam leaves the nozzle with the consideration of 10% friction. Now we are going to do the same problem by means of steam tables. Look at this. The same thing. For first case is friction is neglected. The same formula CT equal to square root of 2000 into heat drop plus C1 square. If C1 equal to 0, it becomes, the formula becomes simplified, 2000 into H1 minus H2. Steam table method. From the steam tables we have to take for 10 bar pressure. This is 10 bar pressure. HG dry steam, so HG we can directly take. Since it is a dry steam, H1 equal to HG1. Since dryness fraction equal to 1, so we can take HG value directly. That is the point you got to understand. So H1 HG1 equal to OK. Now the same thing for finding the entropy, 6.583 at 10 bar. 6.583, that is S1, and we know that S1 equal to S2. So X2 is also known, so we can find H2 by using the formula HF2 plus X2 HFG2. Similarly, S2 equal to SF2 plus X2 SFG2. So S1 equal to S2. So we can, by using that we can find out all the values we can take. H1 everything we can take and substitute. We are finding dryness fraction of steam leaving the nozzle if the friction is neglected is 0.86 without friction. Now we are going for with friction. Velocity of steam leaving the nozzle, by applying the values in the formula we are getting exit velocity as 929.73 meter per second. Case 2. If heat drop is 90%, in the formula we have to have that H1 minus H2 dash C2 dash equal to 8082.02. So this is called nozzle efficiency formula. H2 dash we are finding, P2 dash we know, H2 dash, and the dryness fraction 0.75 bar we have to do interpolation, and we are finding X2 dash as 0.88. So both molar diagram and the steam tables give more or less the same answer. So both are same. So thank you for watching this video. I hope you have understood steam table method as well as molar diagram method with friction and without friction. Thank you for watching this video. Thank you.